Hi everyone, welcome back to class of inferential statistics. So today we will discuss on how we want to construct a statistical test. The sample space A is partitioned into a subset C, where this one is the relation region, and its complement C prime is called as the acceptance region. So if we have the experimental values such that we have x1, x2, x3, xn, and that this point of x1, x2, x3, xn is belong to C, so that means we shall reject the null hypothesis. Otherwise, if we have the experimental values belong to C prime, so that means we shall accept our null hypothesis. This particular point in C that separates the rejection and also the acceptance region is called as the critical value. So let us refer to the first example. So this is an example of random experiment coming from normal with mean theta variance 100. Suppose that past experience with this random experiment indicates that theta is equals to 75, but that now theta is greater than 75. So to test this hypothesis, let's say we take a random sample of size n equals to 25. Let the critical region be the subset C, where we have C is equals to summation Si. We have x1, x2, x3, x25 is greater than 25 times 75. In this case, our critical region can also be written as, let's say we have C. Okay, we have C is just right, x1, x2, x25 greater than 25 times 75. Okay, so it's the same thing if we write summation Si greater than 25 times 75. So it can be written as summation Si divided by 25 greater than 75. So in this case, we will have x bar greater than 75. So that means our rejection region C is defined as x bar greater than 75. But if we have x bar less than or equals to 75, this one is called as acceptance region. So that means our acceptance region is C prime with x bar less than or equals to 75. So the first question, we want to find the power of the test. So let's say we define the power of the test as k theta. So we write, let's say k1 theta for the first test. So we will reject H naught probability, reject H naught under the value of theta naught. So we will have reject H naught is x bar greater than 75, depends on value of theta. Or you just can write as this one. We have x bar greater than 75. Okay, so this is the power of the test. So now we want to find several values at theta equals to 73, 75, 77, and also 79. So that means at theta equals to 73, we will have probability be standardized, so x bar minus mu. So in this case, our mu is our theta, sigma over square root of n. So since our normal distribution is theta 100, so that means sigma square is equals to 100. So we will have square root 100 times 25. Our n is 25. So the same thing, 75 minus theta 100 divided by 25. Okay, if we simplify this one, so this one will give us z greater than 75 minus theta over 100 times divided by 25 is 4, so square root 4 is 2. So now if we substitute theta equals to 73, so we will have probability Okay, so we have theta is equals to 73. So we will have probability Z greater than 75 minus 73 divided by 2. So we compute this one. So it will give us Z greater than 1. So from our stats table, we will find it gives us 0.1587. And then we proceed. We compute theta equals to 75. Okay, at theta equals to 75, the same thing, probability Z greater than 75 minus 75 divided by 2. So we will have probability Z greater than 0. So it gives us 0.5. So the next, we compute theta equals to 77. So probability again, 75 minus 77. So divide by 2. So it gives us probability Z greater than minus 1, which is from stats table, we will have 0.8413. Okay, the last value, we have theta equals to 79. The same thing, so Z greater than 75 minus 79 divided by 2. So this one, probability Z greater than minus 2, it gives us 0.9772. Okay, back to our question. If the two parameter theta is given before this is theta equals to 75. So if we check at theta equals to 75, okay, at theta equals to 75, okay, at theta equals to 75, we will have probability is 0.5. So since it has high probability of rejecting H0, okay, probability of rejecting H0, suppose our H0 is true at theta equals to 75, so our first test, this test does not appear to be a satisfactory test, since we have high probability of rejecting the null hypothesis when our null hypothesis is true. So let us try to devise another test that does not have this objectionable feature. So we shall do this by making it more difficult to reject the null hypothesis, with the hope that this will give a smaller probability of rejecting H0 when that H0 is true. So we try another example. Okay, let us try second example. So this one, our critical region is given as summation Si greater than 25 times 78. So the same thing, we will define our K, let's say K to theta is probability, our rejection region, the same thing, if we repeat same approach, so we will have probability X bar greater than 78. So that's mean our critical region is the same thing, so we will have summation Xi over 25 greater than 78. So we will reject H0 when our X bar is greater than 78. Otherwise, if our X bar is less than or equals to 78, then we shall accept our null hypothesis. So the power function of the test is defined as probability X bar greater than 78. So now we will try to find the powers at several thetas. So we repeat the same process. So let's say theta equals to 73. So K2 73. So we will have probability Z greater than 78 minus theta. So in this case, theta is 73 divided by 2. So we have probability Z greater than 2.5. So again, if we refer to our stats table, it gives us 0.0062. Okay, the next thing, if we try K at theta 75. So again, probability Z 78 minus 75 divided by 2. it gives us probability greater than 1.5. So the value is 0.0668. Okay. Next, we repeat for theta equals to 77. So at theta equals to 77, we will have Z 78 minus 77 divided by 2. So Z greater than 0.5. So this one is 0.3085. While at theta equals to 79, so the same thing, Z greater than 78. So 78 minus 79 divided by 2. So it gives us 0.6915. So if we compare this test with our first test, let's say if we refer the true parameter at theta equals to 75. Okay, let's say if we refer back to this example, we want to compare the true parameter at theta equals to 75. So in this case, at theta equals to 75, the probability of rejecting the null hypothesis when H0 or our theta is equals to 75 is just 0.0668, which is we have a small probability values compared to our previous test, which is around 0.5. So that means the second test is much more better compared to our first test one. Okay. However, if we refer that at theta equals to 77, okay, at theta equals to 77, we will have this one, this probability of theta equals to 77, or we can also use theta equals to 79. So theta equals to 77 and theta equals to 79 is referred as when our H0 is false. Since our H0 is theta less than or equals to 75, our alternative is theta greater than 75. So in this case, theta equals to 77 and theta equals to 79 is considered as when H0 is false. So if we consider that, we have the probability of this one is 0.3085, which is we have, let's say, rejecting H0 when H0 is false is just 0.3. While in this case, for theta equals to 79, we only have 0.69. Compared on the previous test, we have around 0.9. So that means this second test is still unquestionable. Okay, that is, test 2 is not wholly satisfactory. So we should look at more desirable features of another test. Okay, as we proceed in the third example.